Hello and welcome to the Isabellenhütte online video tutorial IVT 3.0 B-sample configuration with Bussmaster. This video tutorial has 5 chapters: configuring and ordering your IVT 3.0, parts and wiring, the IVT 3.0 CAN structure and the BMS control message, IVT 3.0 high voltage channel configuration, and interpreting the IVT 3.0 CAN result messages. In this chapter we will talk about the IVT 3.0 high voltage channel configuration and the placement of the voltage sensing points. Please note that Bussmaster has to be configured just like it was described in the corresponding chapter of the IVTS tutorial video in Chapter 2, Setting up Bussmaster. For this chapter, we will need to have Bussmaster installed on your machine. We're using version 3.2.2, but any other recent version or successor version should do the job as well. And you have to have installed the peak CAN to USB drivers in case you're using the peak CAN to USB transceiver to connect your IVT 3.0 B-sample to your computer. Also, we will need the IVT 3.0 CAN DBC file that can be obtained from your local Isabellenhütte representative or one of our partners. You can see here a simplified block diagram of an electric vehicle high voltage battery circuit. Up top you can see there are those 3 areas: chassis, DC pack and DC link. While we will be mainly concerned with DC pack and DC link for the discussion of how to place the high voltage sensing points in your circuit. I want to quickly go over this block diagram here and explain what we see, just so we're on the same page. So on the left side we have a high voltage battery, we have the plus path of the battery and our first sensing point. We have the fuse on the high voltage plus side, then we have the pre-charge circuit here, the relay on the plus side, the high voltage plus side, the pre-charge relay down below, a sensing point in the pre-charge circuit, the pre-charge resistor, and then we have the DC link circuitry here with sensing points on the positive and on the negative side. Then we have the relay on the negative side, another sensing point, and the fuse on the negative side. And in this case, we assume that IVT 3.0 Pro has been installed on the negative leg of the high voltage battery. And then obviously on the right side here of the DC link circuitry, you have the inverter and the drivetrain of the vehicle. From the IVT 3.0 Pro, you have a line going to chassis ground outside of the circuitry, and then you have virtual measurements ground 1 on the negative side of the battery here on the left side of IVT Pro, and virtual measurement ground 2, which are measurements that are part of the active isolation detection that IVT 3.0 Pro provides. Important to note here is that 3 of the 6 high voltage channels, those are the circles here in red and green, are mandatory with regards to the placement for the isolation monitoring to work correctly. And those are the sensing points 1, 3 and 5, the red ones. On top of that, IVT 3.0 Pro provides 3 more high voltage sensing points, 2, 4 and 6, and these are optional voltage channels. So they technically can be placed in different locations and the isolation detection will still work. Now let's quickly walk through those high voltage sensing points, as these are also reflected in the voltage result messages that we will analyze in the next chapter. So the first voltage sensing points, number one, is the high voltage measurement of the battery. This is in this case that IVT sits on the negative leg of the battery installed on the positive side of the battery. The second voltage measurement point is installed right after the fuse on the positive side of the battery. This is called voltage pack plus in our CAN protocol, or the designations that we use for the CAN signals. Then the third measurement point, which is one of the mandatory ones as well, is the voltage link plus measurement. This is also how it's called in the corresponding result message. And then the number 4 is the voltage link precharge measurement, also called like this in the result message. Also, what IVT 3.0 puts on the CAN bus is the differential DC link voltage measurement, which is the differential voltage between 3 and 5, voltage sensing points 3 and 5. And then voltage sensing point 5 will be the negative voltage link measurement down here, and the measurement number 6 will be the voltage pack measurement on the negative end right after the fuse on the negative leg of the battery. Lastly, the active isolation resistance monitoring will give you 5 different values in the CAN result messages. These are the total insulation error on the high voltage side plus minus, pack, and high voltage plus minus link. So this is a combined insulation error of all the sub-measurements. And then correspondingly it will put out the isolation error on the plus pack side and on the minus pack side, as well as on the plus link side and the minus link side. IVT 3.0 Pro supports bidirectional current and voltage measurement, and it can be installed on the minus side of the battery as well as on the plus side of the battery. And the latter is shown in this simplified block diagram here. This is very similar to the block diagram we just saw. The only difference here is that, as I said, IVT is sitting on the positive side of the battery, and literally like the difference here is that the first voltage sensing point as a consequence has to be placed on the negative side of the battery, and the chassis ground connection has still to be placed for the insulation resistance monitoring to work, but you have to install a 1.2 mega ohm resistor on this line. Now that we went over the placements of the high voltage channels of IVT 3.0 Pro, we will go back to Bussmaster in the next chapter and look at the interpretation of the result messages.